The lesson for today is going to be on section 5.4, reviewing or introducing point slope form. Before we get started, there are a few mixed review questions here. So what I'd like you to do is go ahead and pause and do 1 and 2 real quickly, and then we'll be able to check them. So hopefully you had a chance to go over the mixed review. Miraculously, the answers have appeared, so you want to check your answers there, just reviewing from slope-intercept form and the concepts that we covered in the last section. So today we're going to be going over point slope form. So a lot of times, not every equation is written in slope-intercept form. There are other ways to write the equations. And some forms can be useful for getting different pieces of information. So in point slope form, we can use this if we know the slope and any point that's on the line, to write the equation of that line. Any two equations for the same line are said to be equivalent. So we're going to look at this here. So the definition, the point slope form of an equation is basically this little formula here. So you're going to need to become familiar with this. And what we need is to have the slope and one of the points on the graph. So y represents the variable y, whereas x1 and y1 represent the point that is on the line. M is, of course, your slope, and x represents the variable x. So the first y and the x, those stay variables. The x1 and the y1, you're going to plug in the point. So here again, it kind of goes over what each variable represents. So this would be your y coordinate, your slope, and your x coordinate. So that's where you plug the numbers into the formula for point slope form. Something else, in this equation, we're going to look at some examples and then we'll do a few together. So a line here passes through this point and has a slope of -3. So we want to know what is the equation for that line in point slope form. So all we have to do is plug 5 in for x1, plug -2 in for y1, and plug -3 in for your slope. So that's what they did here. And we can go ahead and simplify. So 2 negatives make a positive. And here we just leave that. We don't have to use the distributive property. So this would be the simplified form. We don't solve for y. We don't simplify it any more than that. That is considered correct point slope form. So let's do one here using that relationship. So write an equation here in point slope form. So a line passes through this point and has a slope of 2/3. So what is an equation in point slope form of the line? So go ahead and press pause and do it on your own first, and then you can check it with my solution. So hopefully you pressed pause and had a chance to work it out or try it on your own first. In this problem here is our x1 and our y1 for the formula. So we're just going to use the formula right here and plug in our values. So I'm going to have y minus -4, because that's my y1, equals my slope, which is 2/3, times x minus, and then my x1 value, so 8. And then we can simplify this a little bit. We can go ahead and change this to plus. So y plus 4 equals 2/3 x minus 8. And that would be considered your final answer as far as just writing it in point slope form. That's how we would leave it, our solution, or the answer, I should say, to the equation. Now, let's look at another example here. We can use the point slope form of an equation to help graph that equation. So the point that's given provides a place to start on the graph. So you would plot the point. It doesn't necessarily have to be the y-intercept anymore. Then we would use the slope from that point to get a few other points to be able to graph the line. So let's look at another example here. This one is already worked out for us kind of step by step, so we can go through this example. So here we have an equation that is in point slope form already. What we want to do is look to see, okay, what point is this going through and what is my slope? Well, the slope is pretty easy to identify because that's going to be your m, which is right here. But I find a lot of students get the point mixed up because of the signs. Remember that the formula includes minus already. So that sign doesn't carry with the number. So if this says y minus 2, that means that 2 was initially a positive value. Same thing here. When it says minus 1, the minus doesn't carry with the 1 because it's part of the formula. So that means that the original one was positive also. So be careful about those signs when you're identifying the point and the slope. That can be a little tricky. So then what we would do is just kind of follow our steps here. So once we have those identified, we would start by plotting the point, which in this case was at 1, 2. So they have done that for us. And then we would use the slope, 1/3, from that point. Now, I feel like they do it kind of the opposite way. I like to always rise first before I run. Kind of makes that triangle there. But you can do it either way. Either way works. I really like you to have 3 points. I know that they say 2 points, but I really like you guys to have 3 points when you're graphing a line in this way. So just make sure that you have 3 points when you do that for your assignment. And we'll do that on the problem next. So example 2 here, we're going to graph this equation using point slope form. So if I look here, I can see right away that my slope is -4/5. So slope is going to be -4/5. Then I can also see that this sign has changed to a plus, and this is my y1. So if that sign's changed to a plus, that means the 7 had to have been negative to begin with, because 2 negatives make a positive. So when I write my point that I need to start with, the y1 value is actually going to be a -7. Then I'm going to look over here. Well, here's my x1 value, and it's minus. That's part of the original formula, so that means 4 was positive to begin with. So my point that I'm going to start with here on my graph is 4, -7. So we would graph that point. I find it a little more difficult to do this with a graph that has a different interval, especially when it's -7. It doesn't work out as nicely, but we'll just kind of have to deal with that. So here is where I would have 4, -7. And then I'm going to need to do my slope. So the negative can go with the numerator, or it can go with the denominator. So I want to go up 4. So I'm going to go up 4 first, and then the negative I'm going to carry with the denominator. So that means I'm going to go left 5 units. So that creates that negative relationship. So from this point, I would go up 4. So 7, 6, 5, 4, 3. And then I would go over and left 5. So I would go over to right about here in the middle. It's kind of a weird location, but I have to be careful of the scale that is being used. So then let's do that one more time. So from this new point, we're going to go up 4 units again. So I'm at -3 right now. So I'm going to go up to +1. And then again, I'm going to go again left 5. So that would put me at -6. So I would put a point right here in the middle. It is nice if you have a straight edge when you're graphing. So I actually am using a ruler to kind of trace my line right now. But when you guys are graphing, if you could have a small ruler that you could be doing your graphs with, that would be awesome. So just remember that's something that will be coming in handy as we do more graphing. Straight edge will be good. So here is my graph using the point slope form. Now we've got a few more examples, but I'm going to run out of time. So I'm going to stop this video, and then I'll start part 2, and we'll continue with the next example.